In 1977, NASA launched Voyager 1 and Voyager 2 into space to study the heliosphere, which includes Mars, Saturn, Uranus, and Neptune. Indeed, the two Voyagers performed their mission and sent data to external space agencies, but they continued on their way beyond the planet Neptune and never stopped until they left the solar system. Today, 46 years after the launch of Voyager, and despite the very long distance they have traveled, they are still working, and we can communicate with them, control them as well, and receive data and images from them. The question that arises here is how, despite these enormous distances, NASA is still able to control Voyager, communicate with it, and receive images and data from it. In general, how do other space agencies remotely control spacecraft and satellites that they send into outer space? But first, welcome to this video from one of the curious Knights. First of all, to understand how agencies everywhere in the world control and send orders to satellites and spacecraft remotely, we need to understand first how the data is composed. Everything we see on computer or mobile screens, whether programs, images, videos, or sound, is essentially a set of connected numbers consisting of 0 and 1. By arranging these two numbers in specific encryption systems, the computer can deal with everything, and 0 and 1 are also the way we deal with devices and give them commands. Anyone who has studied some programming languages knows this, but because we as humans are unable to deal with machine language, there are tools inside these electronic devices that translate the commands that we give to the computer into the language that the computer will understand. Other tools take the outputs that the device produces, which are also in the language of the machine 0 and 1, and translate these codes for us into words or images that we can see, read, and understand. In the same way, all data captured by satellites or spacecraft, whether through sensors or cameras installed in them, is translated into machine language, stored, and then tracked to Earth. On Earth, we still receive this data and translate it again from machine language to data that we can deal with, whether words or images, and the same thing happens when we want to send commands to the satellite. Okay, now we know how the data is formed. How does this data move and reach spacecraft at huge distances? For us to be able to do this, we need to fulfill two important conditions. The first is that we have something with which we can transfer data into the space. The second is that it moves at tremendous speeds. How will this happen? If we look at the waves, we will find them divided into mechanical waves and electromagnetic waves. As we know, electromagnetic waves can move in a vacuum. Their speed is approximately equal to the speed of light, which equals 300,000 kilometers per second. That's why astronomers began to use electromagnetic waves, specifically radio waves. This means that transmission and reception are done via radio waves. But how is data transmitted via these waves? The radio wave is a regular fixed wave like this picture, and it has a specific amplitude and frequency. The data that we want to send to the spacecraft, we take it and convert it to 0-1, and then we upload it to a radio wave. This happens in two ways. The first is by changing the amplitude of the wave that we send so that we have two levels of amplitude. The high amplitude will represent the number 1 and the low amplitude will represent the number 0, and in this way, we get a radio signal of the type M. As for the second method, it is by changing the frequency of the wave. So we have areas where the frequency is high and areas where the frequency is low, which also represent the values 0 and 1, and thus we remain with an FM radio signal. When these modified waves travel in a vacuum at the speed of light, they reach the spacecraft in a short period of time, and the spacecraft receives the wave, analyzes it into machine language, and starts to carry out the required commands, and then sends us data, images, or other things in the same way, so that we can receive them here at the stations on Earth. Space is very vast, and the distances between the planets and some of them are very large. On October 1, 1958, NASA established what is known as DSN, or NASA's Deep Space Network. It is a group consisting of 3 giant radio antennas through which we can communicate with satellites and spacecraft. This network of antennas can communicate with almost all spacecraft that have been sent into space so far. Whether it explores the planets, the sun, or even asteroids and comets, it is the one that sends radio waves, no matter how far or weak the signal is. In order for these antennas to work efficiently, they were distributed at approximately equal distances from each other, so that each antenna covers a third of the Earth's surface area. One antenna is in the Goldstone area in California, and the other is in Madrid, the Spanish capital. The third was in Canberra, the capital of Australia. As for the space explorers on Mars, such as Curiosity, which are roaming on the surface of the red planet now, in order to ensure that NASA does not lose data or communication with them due to the violent storms that occur on Mars, they send with them orbital satellites that are damaged in the orbit of the planet itself and are close to the rovers, and thus communication between us and the rovers remains better. The network is now made up of the spacecraft that is on the surface of Mars, the satellite that is in orbit of Mars, and then the station on the surface of the Earth, especially since the satellites are about 250 or 400 kilometers away from the surface of Mars, and this means that the space explorers on the surface of Mars will not need a lot of energy to send this data.